Welcome to This Explainer. Today, we're diving into a term that absolutely dominated the tech space in early 2026, agent harness. You know, it's one of those buzzwords that sounds incredibly broad, but is actually super specific. And let's be honest, it left a whole lot of us scratching our heads. You might have heard it tossed around as just an environment for an AI agent. But what does that actually mean when you sit down to build something? How is it any different from the prompt engineering or context engineering we've been doing for years? Well, buckle up, because we are going to break down the what, the why, and the how of harness engineering. We'll look closely at the technical loop and see exactly why this shift to a managerial perspective changed AI development forever.
Here's our quick roadmap for today. 1. The buzzword. 2. The context problem. 3. The managerial shift. 4. The technical loop. And finally 5. The autonomous future.
All right, Section 1, the buzzword. So what exactly is agent harness?
Let's get right into it. The term harness engineering or agent harness became official in early 2026, though the ideas behind it were definitely bubbling up just before that. At its absolute core, harness engineering is a powerful orchestration layer. It is a strictly controlled execution environment for your AI agents. Now, to be clear, this doesn't replace the older ways we work with AI. Actually, think of it more as a transformative new layer that gives your AI a massive promotion. It takes the AI from being just a simple worker bee and turns it into a highly structured project manager. It strictly dictates the rules for how an agent starts and finishes every single task.
To really grasp the harness, we kind of need to look in the rearview mirror for a second. Think back to 2022, right after ChatGPT dropped. We were completely reliant on prompt engineering, working inside this tiny 4,000 token context window. That small memory space was a huge bottleneck. Simple prompting just wasn't cutting it anymore. So, to do more with less, the industry evolved into context engineering. We started using neat tricks like tool calling to read files, MCP for vendor features, and RAG to hook up custom databases. And hey, it was a great era. Incredible tools like Cursor, Windsurf, and Klein totally thrived here. But as the underlying AI models got smarter and context windows blew up in size, we started asking these agents to do much longer tasks. And that specific transition, that is what set the stage for the massive leap to harness engineering in 2026.
Which brings us directly to the roadblock we hit, Section 2, the context problem. Why do we even need a harness? Let's look at the exact bottleneck that literally forced this innovation to happen. As the models got better, developers started asking coding agents to tackle massive marathon tasks. Think about asking an agent to clone an entire complex website from scratch, a job that might easily take a human 12 hours. If you tried that with pure prompt engineering, you'd get a sketchy, broken, one-shot website. No surprise there. But the crazy part? Even with advanced context engineering, the results were still surprisingly bad. Why? Well, it all comes down to how context management worked. As the AI's context window filled up with code and text, the system had to use context summarization. It was essentially forced to constantly shrink and summarize its own past work just so it wouldn't run out of memory. This led to a weird phenomenon we can call amnesia. The agent became completely limited by its own ability to accurately summarize what it did 3 hours ago. Compare that shrinking summarizing method with harness engineering, which just throws that old method out the window. Harness engineering demands fresh context per iteration, under incredibly strict rules.
When you look at the actual symptoms of that context summarization failure, it's honestly a bit of a comedic tragedy. Picture this. That 12-hour task is running, the agent's memory gets full, and it starts summarizing its mid-task progress. Well, it would just start making these wild assumptions. It would assume a task was already finished when it definitely wasn't. It would oversimplify crucial steps, just assuming complex features were completely coded and verified. The results were universally frustrating. We're talking partially finished websites, buttons that quite literally did nothing when you clicked them, completely untested features, and totally skipped steps. Now, I want to be super clear here. Context engineering was not inherently a bad thing. But this elastic, squishy way of managing memory gave us this dangerous illusion. It made it look like an agent could handle a long-range project, when in reality it was silently drowning in its own summaries, frantically pretending everything was fine.
So, how exactly do we rescue a drowning agent? Section 3, the managerial paradigm shift.
To fix this massive context problem, the industry realized we needed to shift to a manager-worker analogy. If you look at how the complete system stacks up now, you'll see that nothing actually got deprecated. It's like a giant puzzle where all the pieces still fit. At the absolute center, you still have prompt engineering. That system prompt is crucial. It's what gives the agent its persona, reminding the AI, hey, you are an expert senior coding agent. Then, wrapped around that, you have the middle layer, context engineering. That handles the memory and the tool calling. But the real game changer is what wraps around all of that, the new outer layer, harness engineering. This is the environment. This is the manager. Instead of just crossing our fingers and relying on the agent to manage its own chaotic, shrinking memory, the harness steps in and strictly dictates the workflow from a high-level managerial perspective.
Let's pop the hood and see how this actually runs. Section 4, inside the technical loop and how it works.
This right here is the absolute secret sauce of the harness layer. By stepping one level above the standard context engineering, we lock the agent into a highly controlled, predictable loop. It goes like this. Step 1. The manager generates this massive, overarching requirement document, which is usually mapped out into a clean JSON file. Step 2. The harness steps in and selects just one single isolated task from that giant document. Step 3. It executes that specific task using a totally fresh set of context and a fresh prompt. Step 4. It tests that single step, documents the results, and then it repeats. It loops, iteration after iteration, knocking out single tasks until the entire requirement document is perfectly completed. It is a strict rhythm. Plan, select, execute, document, repeat. This simple loop is exactly what prevents the agent from drowning in those massive 12-hour tasks.
If you remember only one thing from this explainer, make it this: a fresh, clean set of context at every single iteration. That is the magic. Because the harness provides this fresh start under such incredibly strict start and finish rules, the agent quite literally never runs out of memory. It never hits that wall. It doesn't have to desperately summarize what it did 3 hours ago, which means it never hallucinates past steps. It is handed exactly what it needs and only what it needs to complete the single task sitting right in front of it.
And you know what the really beautiful thing about this architecture is? It is surprisingly simple and lightweight. That is exactly why this idea spread like wildfire across the internet and showed up in tons of real-world implementations so fast. For example, there was Ralph, this amazingly effective tool with a tiny code base that perfectly executed this production requirement to JSON loop. Then Anthropic came out and released this super simple, lightweight demonstration environment just to show off this exact harnessing concept in action. And of course, open-source coding agents like Clean jumped right on board. They integrated this directly, dropping their already well-written system prompts right inside this larger looping manager environment. Suddenly, almost overnight, major coding applications were just adopting this harnessing layer directly into their software, simply because the results were absolutely undeniable.
Which leads us perfectly into our final section, Section 5, the future of autonomy.
When you actually apply this managerial orchestration layer to your daily workflow, you unlock these incredible escalating levels of autonomy. Our source material uses the popular tool Cursor as a perfect example of how this scales up. Let's say you're managing a website. At the first level, you've got local sync. You can fire up Cursor locally on your machine to update some text, while simultaneously spawning multiple other agents, each with their own fresh context, to go fix different features at the exact same time. The manager handles all the traffic. But let's raise the bar. Level 2, cloud execution. You can literally just close your laptop, walk away, and the agent keeps running in the cloud, autonomously creating a pull request when it's done. Okay, let's raise the bar again. Slack integration. You can be on your phone, send a quick feature request via Slack message, the cloud agent receives it, gets to work, and just pings you back with a finished PR. Incredible, right? And finally, the highest level, daily autonomous updates. You can actually configure the cloud harness to autonomously check the internet for new AI model releases every single day, keeping your entire website's backend completely up to date without you ever lifting a finger.
And honestly, that is the true power of harness engineering. It took the chaotic, amnesia-prone, summarizing AI of the past and gave it the structured, rigorous environment of a relentless, detail-oriented project manager. It's just a simple loop, but it changes absolutely everything about how we deploy AI in the real world. So I'll leave you with this one question to think about. With the harness acting as the ultimate project manager, ensuring nothing gets forgotten and every single step is tested, what will your agents build next? Thank you so much for joining me on this explainer, and keep building.